good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Luvinda with another video. This is Addition Mathematics Calculus. We have now started differentiation. We are finding using the gradient function from the first principle. Okay, this is for question B. Y is equal to x cubed minus x squared plus 1, like that. So the formula is f prime of x, sorry for that, f prime of x is equal to f of x plus h minus f of x divided by h. So that's your f prime of x. H, we're taking the limit as 0 is equal to x, put x, so h cubed minus x plus square plus 1. Under calculus, the number 5 or the number 1, there is an invisible x. X, what you have to know, it is raised, so it is 5 multiplied by x, 1 multiplied by x to the power 0. So if we sum, okay, if we sum, then x plus h raised to, it will just simply be 1 term, and then multiplied by x plus h raised to the power 0 is just simply be 5. 5 and 1. So this is why I just said plus 1. Let's just add that 1. We just write it. That's the rule that you need to follow. So plus 1, then you minus f of x. So I've substituted f of x plus h. Then f of x is simply this function. Okay? So that function is x cubed minus x squared plus 1. You divide throughout by your h. They are still taking the same limit as h approaches 0 is equal to, we can simplify here, x plus h squared minus x plus h squared. Okay, plus 1 minus x cubed plus x squared minus 1. Then we divide throughout by our h. We can just clean up to create more space. We have what I've done says we add the powers. The value of x plus h to the power 3. So I've just done this to make my life easier. Then before we even proceed, this positive 1 can cancel with that negative 1. That's why we just carry the constant term. This would be equal to so that would be equal to, since we have cancelled out these 2's, we just distribute here x plus h. Of course, we are taking the limit as h approaches 0, x plus h like that, multiplied by x squared plus 2hx plus h squared like that. Then we do the same once again, x squared plus 2hx plus h squared like that, minus x cubed plus x squared. You divide everything by h. Everything should be divided by our h. We are still taking the limit as h approaches 0. This time it would be equal to We can distribute the x in there, and we can also distribute the h in there. So this would be x cubed plus 2hx squared plus h squared x then plus hx squared plus 2h squared x plus h cubed. So I've expanded this. I've distributed the x in here, the x multiplied by everything in here, then the h by everything in here, like that. Then here you also distribute the negative sign, minus x squared minus 2hx minus h squared minus x cubed plus x squared. Everything is divided by h. So as you're taking the limit as h approaches 0, it is equal to, we cancel out what can be cancelled. So we have this x cubed, that x cubed, this x squared, and that x squared can cancel out. Then after cancelling out what can be cancelled, we go to the to group like terms together. So we have this one, which is 2hx squared. Is there anything else having x here? Plus hx. Then we have this one here, plus h squared. Is there anything? This one here, h squared x. If we check, there's nothing else having h squared x, so we can proceed. We just say plus h cubed. So the h cubed like that, then minus 2hx minus h squared. So upon us doing that, we have gotten all the terms. Then we divide everything by h. We clear up to create more space. So we are still doing the same thing. We are taking the limit as h approaches 0 is equal to, if we add those, 3hx squared, we add this plus 3h squared x, we just get that as this is h cubed minus 2hx, like that, minus h squared. We divide everything by h. So the essence of what we do under the first principle is we want every term to have h. So this has h, this has h, that has h, that has h, that has h. So that we can divide by this h. Get rid of this h, because if you divide anything by 0, for example 2, you divide by 0, that is undefined. Okay. So this would be equal to 3x squared, then plus 3hx plus h squared minus 2x, then minus h, like that. So you have divided throughout by your h. And of course this is the limit as h approaches 0. So we are taking the limit as h approaches 0 here. Okay, let's not take the limit. Sorry. Since I've already divided by h, let's substitute. Everywhere you can see h, put 0. This would become 3x squared plus 3 multiplied by 0 multiplied by x plus 0 squared minus 2x minus 0. Therefore, f prime of x would be equal to 3x squared minus 2x. And this is your final answer using the first principle. This is your derivative. Thank you so much for watching. This has been Cornelius Lubinda with another video, and bye bye.